Okay. So I'll just dive right into it. Announced 1 year ago now. This is the second release of new technology. So the parallel to PL1 is Visual Age PL1 had the new technology backend in 1999. Version 5.1 has a new backend for COBOL. And for me, I've been working on COBOL compilers for 33 years now, and this is the first time that we announced, the same day that we announced new hardware, Z13, we announced same day new COBOL that had the same, that had support, exploited that new processor. So we finally caught up to PL1. PL1 and C have done this the last 3 hardware releases, I think. But now, this time we had all 3 compilers, C, PL1, and COBOL, in January announced support for Z13. For COBOL, this is the first time we've ever done that. So we used the SIMD instructions, and I'll show you an example, and more use of decimal floating point for doing math in COBOL. And here's our Darth Vader Star Wars machine. I love this picture. Arch option is now available in COBOL like it has been in PL1 for years, and so now you have to be careful. You now have the ability to compile your programs to always OC1 if you want to. Because if you compile with Arch 11 and run on a Z196, your programs will get instruction check, because this processor thinks that SIMD instructions are data and addends. So you can compile low and run high, but you can't compile high and run low. But PL1 users are very comfortable with this, and help your COBOL colleagues with this. Okay, so here's a sample string operation in COBOL that we exploit the SIMD instruction. So I'm inspecting my string, and I'm going to count in my variable C how many spaces are in the string. And then I have to run this 100 million times to actually get enough CPU to measure. This is actually improved generated code compared to version 4. So 5.1 with Arch 10 had one set of instructions. And I like this example because it shows that the old model, throughout my career, performance tuning meant reduce the path length. Fewer instructions is always good, more instructions is always bad. Wrong. Now, we generate almost twice as many instructions, a lot of vector instructions here, all of these, and yet it uses 97% less CPU to do the same work, which is just, it just makes my brain explode. DB2 even has a tool that they use for release to release back at my laboratory at San Antonio Laboratory in California. When they come out with a new release of DB2, like they compare the number of instructions for an SQL statement in DB2 10 compared to DB2 11, and if there's more, then that's bad, or it used to be. So this is just fascinating to me that the hardware can change so much that it's kind of undone our normal thinking, that we can generate more code and have it not only run faster, but amazingly faster. So doing it a different way is better, it's just amazingly better. So anyway, I don't know how often you look at generated code for your programs, but I just wanted to show this example and show how much Z is changing and keeping up with things. And here's a case of doing math with decimal floating point. These are pretty long numbers, not typical. Normally we would do math with packed decimal instructions, the ones that I talked about that always touch memory, add packed, divide packed, etc. And but they can only do 9 digits, and decimal floating point can do, I think, 60, some huge number of digits, and in registers. So we're even going to do math on data that's already in packed decimal. If you're doing math on a picture variable in PL1 or a display variable in COBOL, there is no instruction in Z to do that. You have to convert it to something else. And for the last 40 years, we've always converted those things, those external decimal data items, into packed decimal and done packed decimal operations, and that's been fine for 40 years. Now we have longer numbers and we have a better way to do it. So even though this data is already in packed decimal, I don't have to convert it to do math on it. I'm going to convert it because then I can use decimal floating point instructions. So again, I'm doing 100 million times to be able to get a measure. In version 4, like I mentioned in the PO1 presentation, we bailed out and called the library routine because we had to do 9 digits at a time and paste the answer back together, and it was just too hard to do it in generated code. In Arch 10 version 5.1, we used the decimal floating point instructions to do the math. In 5.2, we can eliminate everything from DXTR above and use the new, these are Z13 instructions to convert directly into decimal floating point long packed decimal numbers. And so, small change really, but 36% less CPU. So, one of the things to do is tune your system to run faster, and another thing you can do is just recompile your programs to get more throughput and more efficiency. Okay, so as far as compatibility, I understand you're just starting to move to COBOL version 5, so depending on how current the information you read, when we first shipped version 5, it did not support A-mode 24 execution. We fixed that, so if you read something like that on the internet, it's old. And currently, as of March of 2014, we have full A-mode 24 support. So, and one of the questions that customers would ask me is, why did you remove A-mode 24 support from COBOL? And it's really not the right question because we got a code generator that we took from Java, the just-in-time compiler. And that code generator could handle A-mode 31 and A-mode 64, and they never considered A-mode 24. So it isn't really true that we removed A-mode 24, it's just that we didn't spend the effort to put A-mode 24 into our new code generator. But now we did, because in our beta program we had a whole bunch of customers with A-mode 24 assembler programs mixed with COBOL, and they didn't want to redo everything. So A-mode 24 is okay now. So if you read something that has you worried, there's nothing to worry about. And then this is just talking about trying to keep up with changes to make migration as easy as possible. Another set of customers had the older XML parser in their programs, and they had to change them to use the newer ones that were, we only supported the 2 newer ones in version 5 originally, but we added back the old one. So now we're back to having 3 different XML parsers available in COBOL. This is the COBOL standard says if you read a record that's in the gray area between your record is varying clause, so I have 5 to 40, I should have probably 10 to 30, or this should be 5 to 40. My record descriptions should match my record is varying clause. It's not good programming, and the newer compiler will give you a warning if it sees this. The standard says if I read a record that's in one of these areas, I'm supposed to get file status 4. We made that change in version 5, and then customers yelled at us because they didn't want us to do that. They wanted file status 0, like they got with version 4 COBOL. So now there's an option to say, give me the same behavior as version 4. But some of my customers say, this is a good idea to get a file status 4 here because there's bad I.O. things can happen when you're doing this. You can get protection exceptions referring to this area sometimes, depending on the layout of your record areas. So, but most customers say, I don't care. I've been running this way for 20 years. I want to keep running this way. Thank you very much. So we give you the option. I'm going to zoom ahead. We do have to talk a little bit about migration to version 5. And I need to warn you that it's not super easy. If you assume that using version 5 is really easy, you will be mad at me. So I need to tell you right up front. We're finding, like PO1 did in 2000, that there's a lot more use of invalid data in COBOL programs than we thought. We had no idea this was happening. But when we generate different instructions to do some of the work, we revealed that we get different results in version 5 than version 4 in these cases of invalid data. So here's a silly example to show how you could get bad data in the program. And now the compiler, you could argue that the compiler could follow this train and say, okay, well, value 1 has clearly got bad data in it at this point, and I didn't modify it at the beginning of my program, so, but that's a very specific case. This data in value 1 could be coming from a DB2 table or a user input panel in Kix or wherever. So this is just to show how it can happen. 00 space 0 is legal for an alphanumeric picture X data type. Now I redefine it, which is, redefines is a good way to get yourself in a lot of trouble. I redefine this as numeric, and that's okay, that's legal as well, but now I can't use value 1 until I fix the data. Oops, I didn't fix it. So now I'm comparing 00 space 0 to, is that 0 or not? And even in version 4, you could get take the then path or the else path depending on compiler options. And in version 5, it's the same thing depending on whether you optimized or not. You could have value 1 equals 0 or value is not equal to 0. And this is the kind of thing, I hope you don't have these problems. I was just talking to a bank yesterday in the Netherlands, and they haven't seen this at all. They recompile with version 5 and everything's fine and it runs faster, and what's the problem? So I hope that will be your experience. About 1/4 of my clients are having trouble moving to version 5. So we have a compiler option that we added specifically for this to tolerate bad data. We also added a compiler option called zone check. It's very similar to SS range, where we generate a bunch of code to do a if numeric class test on every external decimal or numeric display data item and tell you the very first instant we see the bad data coming into your program, so you can locate the source of bad data and fix it. Some of my customers don't want to fix their programs or their data. They want them to get the same results, and so we have an option called zone data with some sub-options that allow some toleration of bad data and the associated de-optimizing. So if you want best performance, you want to fix your data. If you want compatible behavior and you don't care about performance as much and you don't want to change your data or your programs, then you want to use the toleration option, zone data. And there's a couple of settings for it. PFD is preferred, says all of my zone data is perfect, and so optimize away and run as fast as possible. And no PFD says I have bad data and I'm coming from numproc, no PFD. And zone data mig says I have bad data and I'm coming from numproc mig. It's way too confusing and messy for me, but it's the best we can do. One option for us in COBOL would be to generate exactly the same code in version 5 that we generate in version 4, but then there would be no performance benefit. You have compatibility and no real reason to recompile. So we're choosing to try to help customers get to the more efficient generated code of COBOL version 5. Okay. Another thing we announced with 5.2 in January was access to ZOS JSON services. I mentioned earlier that JSON is our big focus for modernization and web services programming. So we need to hear back. We're actually designing, Peter Elron has already shipped a whole bunch of JSON facilities in version 4.5, and we're kind of patterning what we're doing off what he's done. But we've been asking him, what are your PO1 users talking about what they want in JSON support? And he hasn't gotten any feedback and no reports of bugs, which typically means in IBM, if you don't have reports of bugs in something, no one's using it. Sad but true. So we're trying to do the same thing in COBOL. We're chasing technology, and it's very difficult. We need input. So if any of you have ideas about JSON, about how you would use it, please tell IBM and get it to us. And chasing technology reminds me that when we first came out with XML parse in COBOL in 2001, almost immediately, only 2 months after GA, a customer submitted a requirement and said, this XML parse is fantastic, but I need a validating parser against DTDs, document type definitions. And we said, okay, well, how are we going to do that? That would be very difficult to write. There's nothing available. Luckily, we didn't do it because DTDs died 4 years later and were replaced by schemas. Schema is the way to validate XML documents. So sometimes chasing technology is it's a scary proposition for us in IBM because we might go, well, let's go this way, and then everybody else goes the other way, but we still have to support the wrong way and then the right way. So any help that you have about what we should do in the JSON area would be great. IBM in general is really committed to JSON as the web services protocol. As part of ZOS now, there's something called the ZOS Client Web Enablement Toolkit, which has a parser and generator and HTTP call services, so that anywhere, TSO, batch, Unix system services, CICS, you can do an HTTP call directly from a COBOL program without using WAS or Apache or any of these other kinds of mini subsystem tools. You can do directly from COBOL. There's also something called ZOS Connect, which is a new purchasable product in ZOS, which manages this. I think I mentioned it in the PL1. It manages the workload coming from the web web service requesters to web services. You know, in our view, ZOS is the ultimate web server, and so that's what we're working on here. So, ZOS Client Web Enablement Toolkit was just announced for ZOS, and it's being rolled out by PTF. I don't think the HTTP server is actually available yet, but any day now, very soon. The JSON parser is available, and in COBOL we are working on JSON parse. In the next release of COBOL, we're going to have the JSON parse statement. No, sorry, JSON generate, and then the release after that will have JSON parse. So we're actively seeking input about how we should do these things. Right now we're patterning them much like we do XML parse and XML generate, and doing things like XML parse today is quite difficult to get all of the data from an XML document into all the data items in your COBOL program. And we are going to have a parse statement that where you can say, parse this JSON into this structure, and just one statement, move it all over, and we'll find the matches and all that kind of stuff. You don't have to have input and output procedure or the processing procedures for your XML parse. So we are taking advantage of lessons learned about how difficult XML programming was in COBOL, and so JSON programming will be easier. Okay, so why did IBM do ZOS Client Web? ZOS Client Web Enablement Toolkit. It's a real mouthful of words there. There were a bunch of different things. I actually did an experiment last year to present to GSE Nordic about doing an HTTP web service request from a COBOL program running in ZOS batch. That was very interesting. So going through Java to Apache and making an HTTP call. So there's DB2 has some things, Kix has things, WAS has facilities. A lot of different areas within IBM have separate solutions to the web services communication problem. Now we have a generic web service facility available to everybody running on Z with the ZOS quality of service, etc. So now there is a general usage JSON parser available in all environments. Yes, sir?
What's WAS? I've heard you say it a few times.
Oh, WebSphere Application Server? Yeah, someone else said call it WAS earlier, I think. Have you heard of that? It's like a CICS, but more kind of web focused.
Okay, we use WebSphere. I've heard that term thrown around a lot. But
Yeah, a lot of people, I have a problem with that. I'm a picky engineer, geek, but we had a whole series of tools called WebSphere. WebSphere Code Generator, WebSphere MQ, WebSphere this and WebSphere that. So WebSphere is sort of a brand. But actually in IBM, a lot of people, when they say WebSphere, they mean WAS. WebSphere application server. It's one of the WebSphere tools. So I apologize, I should use common terminology, but WebSphere can mean 15 different things to me. WebSphere application server is a specific thing that has a bunch of facilities for enabling web services and enabling Java and COBOL interoperation with Java and things like that. Okay? All right. So the announcement was that we added in, they didn't have a good place to advertise the JSON facilities of ZOS, so we helped out by adding it to our announcement. You can actually use these things from any COBOL or PL1 or any language, really, assembler. This is kind of what it looks like. It's a call-based interface. So it's pretty, I would say, in the United States, clunky. It's pretty ugly to do this. So I have to initiate the parser and then set it up and then pass it some data and then call it again and call it again. That's why we are going to have something that just says JSON, parse the JSON document into my O1 level group and be done with it. So it'll be one line instead of 200 lines. But you can do this today. This is available right now for any program can do these calls. And I'll start with HWT. Okay, so new features of version 5.2. Oops, I have
50.
how much? 15. Oh, good. I thought I only had 1 minute. I have to go really fast. Okay, so a new qualify option. That's a request from GuideShare Europe. A rules option looks familiar to PL1 folks, and now we've copied. We want to be just like PL1. But it's a really good idea to have the compiler tell me things about my code that could help me be a better programmer or help my program be better. Ways to track your executables after you've shipped them. And then these are compiler options that were added. So we're being quite dynamic about COBOL version 5. We don't wait for the next release. If customers need something right away, we ship it as soon as we can. So one of the things we recommend with version 5 is keep up with maintenance. Install the very latest maintenance because the compiler is changing day to day. I also recommend if you haven't done 5 yet, go straight to 5.2. Don't do 5.1. They're the same as far as migration ease or difficulty, depending on where how your data is in your COBOL programs. But 5.2 has a bunch of new features that make it much more attractive. So since it's the same amount of work to get to either one, get to the one that has more features in it. And then this is going to be our roadmap for the future. Every time there's new hardware, COBOL and PL1 will announce support for the new hardware and add a new Arch setting and remove an old one. So it's going to be a sliding. We're not going to support 17 Arch levels that have to test all the combinations. This is a real challenge for us in compiler development. We have to test all the different Arch options and somehow have a whole bunch of different hardware around, whereas our system people say, we only want new hardware. No, we need old hardware too. And we need to run our tests over and over and over again with different optimized levels and different Arch levels, and optimize 1 with Arch 9 and optimize 2 with Arch 10, and oh man, it's tricky. So we are only going to support this 5, I guess, settings of Arch from now on. So it's going to be a sliding scale. One of the things that we did or didn't completely do in 5.1 was merge the storage management between the front end of the compiler that scans the source code, gives you syntax errors. If you have any, you don't have any, but when I write COBOL, I have syntax errors. The compiler tells me what they are and I fix them, and it generates a dictionary of all my variables in my program. Then it passes an internal representation of my COBOL statements to the backend, and the backend works towards getting to machine code and allocating registers and optimizing. Well, the size option used to control the storage for the entire compilation. Then we kind of patched in this new backend, there was a kind of a conflict where you could have a large size setting would take away from the back end and cause the back end to fail. But if you had too low of a size option, you would have some
Someone
noise
was
up
calling
there.
Morten.
Oh, I have a meeting, it's probably it's almost morning, no, it's not, it's middle of the night. If you set size too small, then the front end wouldn't compile, and if you set, wouldn't work, and if you set size too big, the back end wouldn't work. So we fixed it, we removed this option completely. Now the compiler just goes by how much memory is available, and by the way, that's a lot. COBOL version 5 takes 20 times more memory to do a compilation than COBOL version 4 did. So COBOL version 4, you can set a 10 meg region and compile most programs. COBOL version 5, you need a 200 meg region. So the PL1 users went through this in 1999. Our newfangled code generators take more storage. So when you give us 200 meg, the front end uses part of it and then frees it all and passes it all to the back end. Whereas before we didn't do that in management very well. So we kind of completed the integration of the new back end into the compiler in 5.2. This is sort of a kind of a little bit of a maybe push the product out the door too early problem. So 5.2 has a significant ease of use feature in that the size option is gone. And I'm disconnected. What happened here? I need to click on my screen. Okay. So here's this qualify option was another thing that's nice. I think I mentioned that the COBOL team grew tremendously in IBM, so we have more resources to add features to the COBOL compiler than we did for the last 15 years up until 2008. And suddenly we had this much larger team. And so now we can do things like satisfy user requirements. Instead of just barely keeping up with the minimum, we can do nice things. The nice to-dos can now make it onto the list of things we're doing. So this qualify option introduces the concept of a complete set of qualifiers. And here's the challenge that the client had. They had data structures coming from somewhere else that they couldn't change, but they had to use somehow. And in this data structure, you can see there's 2 A's and there's 2 C's. This A cannot be referenced by COBOL standard rules, and neither can this C. I can have C of B of A, that's unique. But if I say C of A, that actually refers to 2 different ones by standard rules. With the qualify option, qualify extend, I add the concept of if the list is the complete set of qualifiers. If there's only one data item that has C of A as the complete set of all the qualifiers, then I will resolve to that. So now C of A means this one, means the level 2 C. And I can also say, you reference A now, A is only the complete set of qualifiers for this A. A complete set of qualifiers for this one is A of B of A. So, might be useful, maybe not. It wasn't too hard to do, and it was a user requirement. It came from clients in Germany, and they wanted it, so we did it. Similar to PL1, we now have a rules option with initially 4 sub-options. PL1, I think, has 60 or so. It has pages of sub-options for rules in the manual. No end periods helps you write COBOL in a period-free way, which is the correct way to write COBOL. You shouldn't use periods to terminate conditional statements. You should use end if and end evaluate and end read and all those nice explicit scope terminators. Some of my clients want to turn this option on. It gives you a warning. And then you can use the compiler message customization to force that warning to be return code 12. So you absolutely forbid your programmers from ever terminating conditional statements with periods. And the danger, of course, I hope you're aware, is that just by hitting a space bar and getting rid of a period, I can completely change the algorithm that I have in my program. And I don't know it happened. You can't accidentally get rid of end if with one bump of a space bar when you're turning around to say, what would you like? Tap, ooh, I changed my program, it doesn't run anymore, don't know why. So, kind of a nice thing. We've had some issues with overpopulated data items moving to COBOL version 5, where I tell the compiler it's picture 9.2, but I actually have 3 digits in it, so I'm lying to the compiler, and generated code can get different results between version 4 and version 5. So this says, well, if you should never define a packed decimal data item with an even number of digits, because in the hardware, you either get 1 byte, 1 digit, 2 bytes, 3 digits, 5 digits, 7. There's no such thing as even. If you define even, then you have an unused nibble of space that could cause trouble someday. So we can help you find those. PL1 has this as well. Don't be lax about my bad performing COBOL statements. Tell me which ones I should improve if I want to make my COBOL program run faster. And then this one also came from clients in Europe. They wanted to know when the compiler was adding slack bytes in as a result of the synchronized clause. Now, and just yesterday a client said, well, isn't synchronized kind of historical? And it is. There is no benefit now to putting a binary data item on a full word or double word boundary like there was in ESA in 1985. Now the hardware does a load or a store or whatever, or math on binary data items just as well if they're on a 1 byte boundary or a double word boundary. So, but you might have synchronized in your copybooks and it might accidentally add some bytes in there. And customers want to know, well, when are you adding the bytes and where? So that I can name them and have all of the fields in my structure be named and explicitly called out. LaxPerf talks about things like doing a perform loop and using a variable data type. This is hidden math. When I'm doing perform varying, I'm doing a whole bunch of math on that variable. So I shouldn't do varying of an inefficient data type. And I shouldn't have all of the different operands of perform varying be different data types so that the compiler has to find a common denominator. I have packed decimal, I have binary, I have float. Let's see, what can I do? All of this math together, I have to convert all the parts. So accessing tables with inefficient subscripts, moves that result in the conversion of data from one type to another. If I just code move A to B, I might not be realizing that I'm actually doing an expensive conversion there. You might want to do it anyway, and that's why you would never force these to be return code 12, because some of them, I really do want to do padding of this entire 32,000 byte field. I might want to have it all be spaced, and I know I'm doing that. Or it could be that I didn't know that from field to field was going to result in moving 32,000 bytes and slow my program down a lot. And so this can help you there as well. And then it flags compiler options that are non-optimal. And as soon as we shipped this feature, customers said, can I turn that off, please? I don't have control over what compiler options I'm using. I have control of my source code. So this is not interesting to me, make it go away. And we're working on that. Okay, so copyright for vendors who ship COBOL applications in executable form, they might want to have their copyright. Service is more for you. You can look, when you're doing software archaeology and looking at your executables in your PDSE dataset, your PDSE load library. We have PDSE load libraries here for COBOL, or PDS. Do you know? This is the challenge. PDS? Uh-oh. Got to change to PDSE for COBOL version 5. So we only generate program objects with COBOL version 5, so they have to be in PDSE datasets. But, so you're looking in your load libraries and trying to figure out things about your executables. You can, we have tools in IBM, Load Module Analyzer, there's outside tools that do it as well, that tell you which compiler version and release, what compiler options, and now you can also say, what's the service level? Which PTF did I have on that compiler that was used? So you can track, well, that bug was fixed by IBM, why is this program showing it? Does it have the fix in it? So we recommend that you set the service string, your people in control of your COBOL compiler, set the service string to some kind of an indicator. You can write 64 bytes in there that says, this is the service that Hans put on in January or something. Or you can have a PTF number or whatever you want, or all of the above. Could be helpful. Improved XML generate, volatile call interface. These are kind of interesting. XML generate is improved. Every release we've improved XML generate. This is an option to de-optimize a data type. I'm going to skip that. This is a user request that's been over 15 years. The customers wanted to do DLL calls and dynamic calls from a COBOL program. And you could never do this before. You had to have a wrapper to do the DLL call. Now I have a directive greater than call interface, and I can say this call is going to be DLL, any calls after this point are going to be dynamic, and now I'm going to turn off any specification by call interface and use my compiler option, because I can compile with dynam option or DLL option. Gives a lot of flexibility. Some customers I talked to yesterday thought it was a horrible idea because looking at a call, you couldn't tell what kind of call it was. You'd have to back up and see which call interface was in effect, which I thought was a reasonable. They wanted a different kind of call statement. But this directive is from the standard, and the standard just has CALL instead of, well, DLL call or dynamic call or have some kind of new statements. But it's an interesting thing to look at. We'll be interested in feedback. But this was a way that we could allow customers to do both DLL calls and dynamic calls in the same program. 2002 COBOL standard, which is continued in 2014, and a new standard was approved. And we've been adding features from the 2002 standard steadily. My clients have asked me, you know, we want 2002 standard support, and I said, well, no, you really don't, because the parts of it are not useful. There's an entire screen handling section, and COBOL is not the language to do user interface coding. That's HTML, JavaScript, and those kinds of things. So we're never going to do screen handling in COBOL, even though it's part of the standard. And none of our clients will, correct me if I'm wrong, I've never heard anyone say they wanted to do screen handling in COBOL anymore. That's more 1985 kind of thing. But there are a bunch of good things, and we've added a section in the programming, in the language reference manual, with a list of all the parts of the COBOL 2002 standard that we have already done. And so now you can see the progress we've been making in that area. And here's a bunch more things. Exit improvements, partial word replacement with copy replacing, and nested copy replacing. This has been a long time user requirement to allow copy replacing with nested copy statements. So here, oh, and this table sort statement where now you can do a table sort in Kix. You can do it anywhere. You couldn't do any kind of sort in Kix before because we would call df sort or sync sort, whichever external sort facility, and those were forbidden in Kix. Now we can do table sort without a sort file definition, an SD. There was a way to do this in the programming guide that had using input and output procedures and return and release and pretending that my table was a file, and it was very messy. Now I can just say, sort my table, please, and tell it the ascending key. In this case, my ascending key is data key, so that's my first character, and keep any duplicate keys in the original order they came in, tell the collating sequence. So now I have a sorted table, and so now it's much more easy to use binary search. Search all requires that the table be in ascending order, or in an order. Could be descending. And so now I have that. So here, the B came twice with Y before X, and I have Y before X, duplicates in order. Exit enhancements, go straight to an example. I'm in S1 section, paragraph P1, and I say, you know what, I'm done here. I want to exit this paragraph, and go to the next paragraph. So this one is analogous to go to P2. But if I change the name of P2, this exit paragraph will still work, whereas my go-to would fail. So it's more flexible, and you can stop using go-tos. You can still do go-tos, they're just not called that anymore. Exit section says exit the section I'm in and go to the next one. So it goes to S2. And then the really cool one, I think, is exit perform. I'm in a loop here, performing 10 times, and at some point I can say, I'm done, I'm out of here. I've gotten what I need out of this array, leave the loop, and go past the end perform. Or I can say, I've done enough on this iteration, but I still want to go through more of this table, so just exit this cycle. And so it goes to just before the end perform. This one goes to just after, this one goes to just before, and then goes back up and does another iteration. So PL1 users already had this, and C users, and now COBOL has this. Improved copy replacing. You can now do partial word replacement, and you can have nested, and I'll go straight to the nested example. So I'm copying in a copy number, including a header file, you might say. And I'm going to replace leading department with payroll and trailing gross pay with net pay. So then here's my copy member that I'm copying in, and it has some things that start with department and end with gross pay, but it also has a copy statement in it. So this is a nested copy, and this has some things that should match, and this would not work in COBOL version 5.1 or earlier. Now, it works just fine. Even the copy member that was brought in by nested copy gets the replacement happening, payroll and net pay. So, a user requirement and standards implementation. And then just a high level, migrating, once you're on version 5, you don't have to worry about migration. But migrating from anything older to COBOL version 5 is different from any time in the past 30 years. It's similar to moving off of OSVS COBOL to VS COBOL 2 back in 1983, where we have a new instructions generated which could get different results for invalid data. We don't know if you have invalid data in your programs. You'll find out when you migrate to version 5. So we recommend lots of regression testing. The nice thing is you'll get what we generally say a 10% performance improvement going to version 5 from previous. Up to one client had an application they recompiled and didn't have any problems with bad data, by the way, and it ran 70% faster, 70% less MIPS just by recompiling, and they got exactly the results they wanted. So the potential gains and money savings are quite large. But it's not, I'm not going to say that it's super easy to get there, because my clients who went at it thinking it was super easy are really mad at me. So I want you to know not to be surprised, be cautious. And we have compiler options that we recommend, a new migration strategy of compiling with SS range and zone check to do your initial exploration of COBOL version 5, and then turn those options off and test again when you go to production. So, only 6 minutes over my time.
Yeah, that's okay, so. It was very
Any
interesting.
questions? I will talk a little bit about some programming guidelines and practices, as if I'm the expert on programming, but I do have some ideas that can help you, and you can probably help me as well. But that'll be a shorter presentation after lunch. Right?
Thank you.